Hello, everyone, and welcome to today's webinar on best practices for content delivery using Amazon CloudFront. My name is Nihar Bihani, and I will be your presenter today. I also have a few other folks with me here. We have Jared Guthrie and Venkat Vijayaraghavan. They're also product managers that work with me. They're my colleagues. And then also Colleen Namesh. He's a support engineer, also a colleague of mine on the CloudFront team. Jared, Colleen, and Venkat will be our Q&A moderators. Just a little background about myself. So I'm responsible for product management for Amazon CloudFront, which is AWS's global content delivery service. I joined AWS in 2009 and have worked in a few different roles at AWS since. I've spent the last few years working on the CloudFront product. Before we begin, I wanted to walk the audience through a few items. On your screen, you will see a Q&A panel. Please submit your questions at any time during this webinar. Jared, Colleen, or Venkat will answer as many questions as time allows while I'm presenting. And also towards the end of the webinar, there'll be a live Q&A session, and we'll all try to address as many questions as we can. And lastly, this webinar is being recorded, and we will share the presentation slides via email a few days after the webinar. So with that, we'll go ahead and get started. Quick overview of the agenda. What I wanted to talk about is talk briefly about what is Amazon CloudFront. Several of you may already be using CloudFront, whereas others may just be starting to look at CloudFront for content delivery. So a quick few slides on CloudFront and some of the recent progress we've made. And then focus the majority of the time during this session talking about some of the best practices that we on our team hear from customers when we interact with customers, and also weave in there some of the inner workings of CloudFront to help guide sort of your thinking and how you architect your applications and make most out of your content delivery network, CloudFront. So in terms of CloudFront's presence, we have a growing global footprint. We have 53 edge locations today worldwide. Across 37 countries and 37 cities, and 19 countries. So as you can see in this map, the blue dots that you see are CloudFront edge locations, and the yellow bigger dots or circles are the AWS regions where EC2, S3, and many of the other AWS services are. In terms of features and functionality, one of the things that we continue to do on the CloudFront team is listen to our customers, understand what their needs and requirements are, and iterate quickly to launch new features and functionality. And as you can see, just in the past 12 or 13 months, we've launched a number of different features as well as a few edge locations. And we expect to see this trend continue where we keep hearing feedback from our customers and understand what are the highest priority features that we need to build, and then iterate and deliver those quickly. So I won't go through every single feature detail that we've launched here. That is something you can find in on the AWS website. So there's a What's New page, which talks about all of the CloudFront feature launches and provides you relevant links to documentation. So let's talk a little bit about CloudFront and capabilities that CloudFront has. So you can use CloudFront to deliver your entire application or your entire website. That includes your static content, which may be the images on your site, your video content. It could be on-demand or live video streaming. It could be dynamic content, so content that is personalized on your application or on your web page. It could also be user input, so when you have a search box or a login form where you're doing a post or a put request back to your origin server, that could also be proxied via CloudFront. And then finally, you can use your own SSL certificate and deliver all of that content over HTTPS. So when you think about a typical web application, when talking to customers, I like, three different portions within an application stand out. One is static assets, second is dynamic content, and then third is the streaming media. So what I've done is I've tried to organize the best practices that we'll talk about today around these three different types of content, and then towards the end we'll also talk about some general best practices that apply to all types of content. So static assets. Static assets are your images, CSS, JavaScript files. These are the contents that don't change very frequently. So this is static. You can think of it as your website, Chrome that doesn't change very frequently, fonts, and even things outside of a website. So it could be a software application that your customers are downloading. The key here is that this is a single file or a small number of files that are distributed to multiple users. So multiple people around the world are downloading the exact same object or exact same file. The state of the object doesn't change for a period of time. That period of time could be seconds, minutes, hours, days, even, and that's what makes it static for that portion of time. And caching is just a way to serve static content to more than one user with low latency and high performance, where not every user has to come all the way back to your origin servers, and instead you can distribute that content out to the edge of the network, closer to your end users where they can download it from. So the best practices, when you think about best practices, the pattern that you'll see throughout this presentation is there's a number at the top, and that denotes a best practice. So to get started, if for static content that you're delivering to your end users that may be a part of your web application, one of the things that I always tell customers is use Amazon S3 for your static assets. There are many advantages of using Amazon S3. It's highly scalable, highly available object store, and it helps decrease load on your web server. So just by using Amazon S3, you don't have to worry about scaling your origin servers as your demand increases for your content. That's something that S3 can handle naturally. S3 can deliver that content to CloudFront, and then CloudFront can cache it at the edge and then deliver it to your end users. And just a few months ago, we also introduced a pricing incentive where S3 to CloudFront data transfer is free. So any data that's delivered from S3 to CloudFront, when CloudFront doesn't have an object in its cache and needs to go to S3 to pull that data transfer is at no additional cost. You can also control access to content on Amazon S3. So if you're thinking that, hey, some of my content is private, I don't want it to be publicly available. I only want to deliver it via CloudFront to my end users that I want to deliver it to. Then you can use origin access identities. And origin access identities are basically users that you can create that have access only to your S3 bucket. So it's a special CloudFront user. This is part of CloudFront's feature called private content, and there's a lot of documentation around how you can configure and implement private content. But what I wanted to highlight is if you do have private content, you can use S3 along with origin access identity to make sure that your content is not leaking, and that your S3 URLs are not used anywhere, so that, as you can see in that diagram, a user can't get directly to S3 and download your content bypassing CloudFront. You can also control access to your content delivered via CloudFront. So in addition to blocking end users from going directly to S3, you can also implement signed URLs or signed cookies, which are two different mechanisms by which you can have your end users, only the end users you want, have access to your content in CloudFront and download it from CloudFront. So you can see then the combination of having signed URLs or signed cookies and then origin access identities can provide you end-to-end access control on who can download your content from either S3 or CloudFront. Signed URLs or signed cookies, the way they work is you build a policy that you can include either as a part of the URL as a query string or as part of the cookie. You can set a set cookie header, and your application would need to authenticate these users and either sign the URLs for users that are authenticated or write a cookie. And once that is done, CloudFront can now understand the signature in the URL or read the cookie and look at the signature inside the cookie. And then at the edge, CloudFront can decide whether or not to allow this user to download your content. A couple of examples, signed URLs you can use in a marketing email. So for instance, if you are including a link to some content or a video in your marketing email, you can sign that URL. and make sure that only users that you sent the email to that received your email will have access to that content. Signed cookies is something you can use for streaming or for whole site authentication, whereby just by writing one cookie for that domain, all content under that domain a user could access. So for streaming, the application there is when you're delivering your media files, your chunks, or your fragments, the user can have access to all of your fragments without you needing to change the URL at all for each fragment. One of the other things that I always encourage customers to think about is think about caching at every layer. And this includes and should start always with browser caching. Because if most browsers will have a small amount of cache available at the browser, and this has a huge advantage. So if you set your cache control max age header, which most browsers will respect, then you can have the browsers cache your content so that the browsers can deliver it locally to that viewer the next time that viewer goes back to that page or to that content. And the browser doesn't even have to go over the network, even to the CDN, and try to download it from the CDN edge. HTML5 application cache, IE, Chrome, Firefox, they all have local caches available. So the way you configure this is by configuring the cache control max age header. The example I have here is 3600, which is in seconds, so that's 1 hour. So you're instructing the browser to cache that object for 1 hour. You're also instructing in the process to cache the CloudFront Edge node to cache that object for 1 hour. And when you think about caching at every layer, in addition to browser, you can also think about edge caching and how you can possibly instruct the edge to cache the object for a shorter or longer period of time than the browser. So you can set high TTLs, for instance, for intermediary caches. So you can set a S-max-age, which is another cache control header. So in this example, I have S-max-age set to 86,400, which is a day, specified in seconds. So now CloudFront will honor the S-max-age, or any other intermediary cache, such as a corporate proxy, will honor the S-max-age for 1 day, but the browser is instructed to cache that content via the max-age header for 3,600 seconds, or 1 hour. So the browser may check with the CDN edge node every hour, but the CDN edge node is instructed to keep that object and not go to the origin for at least a day. So you can use these two different cache control headers to, for your use case, to decide how long you want the object to be cached by either an intermediary proxy or the browser. The other thing is, from an edge caching perspective, you want to maximize the cache hit rate at the edge so that the edge node has to go as few times as possible back to the origin server to get the latest copy of your content. And one of the ways to do that is, in addition to setting a high TTL, is to not forward any headers or query strings or cookies back to your origin server. So when different clients are making a request at the edge node, the fewer variations that exist of that particular object, whereby any header or cookie or query string will create a new variation of that object. So the fewer the variations, the fewer times the edge node has to go back to the origin, and instead the edge node can simply respond back with object that's already in cache. So this helps improve performance and also load on your origin, or lower the load on your origin. One caveat to forwarding headers, query strings, or cookies is that if you're doing course, or if your application is doing course, and if you have, for instance, with S3, the course functionality enabled, then you do need to forward certain specific headers to the S3 bucket to enable the course functionality. But there, what we recommend is you only do that for the objects where you need the course functionality. So you can create a separate CloudFront cache behavior, which we'll talk about in a minute, to forward those headers only through those cache behaviors. So for most users, for most use cases, when it comes to optimizing the cache hit rates at the edge and making sure that objects are cached and stay in cache as long as possible, using CloudFront defaults can achieve all of this. So you don't have to think about what to forward and what not to if you just use CloudFront defaults that allows you to maximize your edge caching. Now, objects can change and will change over time. So if you set a high TTL, which is one of the things I talked about, but your object has changed, versioning is a great way for you to be able to update that object at your intermediary caches, at the edge cache, as well as in the browser. So you can use a file name or a query string to version your object. You don't need to make any additional API calls, and still continue to have high TTL set on your object. Each version, whether that's the version is done via a file name or a query string, is treated as a unique object in the browser cache as well as in the edge cache. So let's talk a little bit about dynamic content. Dynamic content, think about things like your HTML pages that changes very frequently, your shopping cart that has unique objects that your customers are shopping for. So it's there are three different, when I think about dynamic content, there are three different types of dynamic content. It's content that's unique to every request, like your index.php. It could be content that changes very frequently, but it's not necessarily unique to every single user or every single request. So this is things like weather updates. So the weather data changes frequently, maybe even every few seconds. But it's not necessarily unique for all your users in a given zip code. They're getting the same weather data for the next few minutes. And then also there's content such as search results that is unique based on the query string. So if you're searching for books on the Amazon.com site, the search results that come back that are specific to that keyword, books versus DVD players. So there's customization based on the query strings as well. So even when it comes to dynamic content, one of the key learnings or discoveries that we often make with customers is that a lot of your dynamic content can also be cached. The way to think about it is the content is dynamic unless it's every single request has unique response coming back from the origin. There are patterns that you can identify where you can cache your responses for a certain amount of time, so that any other users that come after for that duration of time and that are looking for the exact same page with the exact same query string parameter or for the exact same weather data for the same zip code, they can get that content directly from the edge, and the edge does not need to go all the way back to the origin. To enable this, CloudFront supports TTLs that are as low as 0 seconds, so you can set any TTL value and you can cache those responses for any duration of time. CloudFront also honors no cache and no store header, so depending on your use case, you can specify those headers on how you want that dynamic content to be treated. Most content, like I said, most content can be cached even if it is for a few seconds, and the benefits are CloudFront will support if modified since or if none match. Even if you're setting a short TTL on your dynamic content, CloudFront, once that TTL expires, CloudFront will go back to the origin server and do an if modified since to see if there's an updated version of that object available. And if not, then it'll just refresh the cache without downloading the entire object all over again. The other benefit is, if your origin is unavailable or inaccessible to CloudFront for whatever reason, then CloudFront will continue to serve stale content even if the TTL is expired. So this is an availability feature that we'll talk a little bit about further down the deck. But I wanted to highlight there that even for dynamic content, this can ensure higher availability for your website. So one thing I wanted to highlight is when you think about your dynamic objects, one way to identify what can be cached, even if it is for a short period of time, is by looking at the CloudFront popular objects report in the management console. You can find objects where you're seeing a high miss rate or a very low hit percentage because you're not caching that content currently, and then see if some of these objects could be cached for a certain period of time. So that's an evaluation you have to do to understand how frequently some of these responses change on your web server, and accordingly you can put the right cache control headers, even if it is for a few seconds, to increase that cache hit rate. Because as you can see here, you're getting multiple requests. So if you look at the /API getBooks category equals math, you see that you're getting you've seen 100 requests for this exact object, which you may have thought of as a dynamic response from the origin, but it looks like 100 people are requesting for that exact same dynamic response. CloudFront has cache behaviors functionality. So what cache behaviors allow is for you to segment your web application based on URL path matches. So you can set different caching configurations for different content on your application or on your site. And so the way you can take advantage of cache behaviors, one of the ways is by only forwarding the headers that are required for objects that live inside that cache behavior. So for instance, if you have a cache behavior for /images, where all of your images are, your images, unless your images are changing based on header values, you can not forward any header values to the origin and just have the origin respond back with the regular with the same image file and have that be cached at the edge. You can also avoid forwarding the user agent header and instead use some of the headers that CloudFront provides, such as the CloudFront-is-mobile-viewer, where CloudFront identifies a mobile viewer or a tablet viewer or a desktop viewer or a smart TV viewer. And the way this helps is user agent string. When you forward the user agent string back to the origin, CloudFront will make that a part of the cache key. And the number of unique user agents that are out there that may be accessing your content, it's such a large number that you will end up with multiple copies of the exact same content in your in the CloudFront edge cache. So to avoid that and to lower the number of copies so that you can increase your cache hit rates and minimize the number of times your end users have to wait for CloudFront to go back to the origin, you can use some of these mobile, tablet, desktop, true-false user agent translations, and then make your origin decisions based on that to be able to customize your response still for a desktop viewer versus a mobile viewer, but not have to forward the entire user agent header and affect your cache hit rates. The same logic applies really with cookies as well. So instead of forwarding all cookies, in particular, something to be careful about is the session ID cookies, where it's unique for every single user. You can only forward the cookies that you really need for your origin server to look at the value of and then respond back with the custom content. So let's talk about streaming media a little bit. What is streaming media? So streaming is, could be live media content. For instance, if you're broadcasting a live concert, or it could be on-demand content, such as a recent movie that your viewers are going and streaming and viewing on your application. Could also be just audio streaming, so just the audio files, whether it's podcasts or music. So typically, streaming content involves three different types of assets. It's the manifest file that describes all of the different fragments of your streaming media file, the media fragments themselves, and then often some of the player assets if you're having your users download a player along with your media content. So from a best practice perspective, since CloudFront allows you to set any TTL, you should really think about what TTL you should set for different types of streaming media content. So for the manifest file, this is something that's updated frequently, particularly for live streaming. So you can set a very low 2-second TTL so that within that 2-second time frame, all your viewers that are trying to view that live concert can download the manifest file from the edge cache. But after the 2 seconds, the edge cache or the CloudFront Edge will go back to the media server to get the latest manifest file that describes the newer fragments. The fragments themselves could be cached for longer, so such as 60 seconds, because they are, for the most part, static and they're not updated. Once generated, a fragment is not changing. And then the media player could, for instance, live in Amazon S3, and the player files are, once they're set, they're not updating at all. So you can set a very high TTL on that. The other thing as you're doing streaming is to think about is setting or using HTTP-based streaming protocols. So when you're using HTTP-based streaming protocols, you can use CloudFront's web distributions to deliver multi-bitrate streaming. And HTTP has a lot of inherent benefits, such as it's a standard protocol that can get through the corporate firewalls. so you don't have to open up ports. And it has widespread support across different devices. Intermediate caches can cache the content and so on. For live streaming, you can use CloudFront along with media servers running on Amazon EC2, and we have tutorials available on our documentation on how you can set up live streaming. For on-demand streaming, you can use multiple formats, whether that's smooth streaming, which CloudFront has native support for, so you don't need to run a media server to do on-demand smooth streaming. You can just put your media files in Amazon S3, and then CloudFront will deliver it in smooth streaming format to the clients, as well as HLS. One of the other recommendations here is to try and not forward any headers, cookies, or query strings. So for your streaming content, one of the ways in which CloudFront is effective in scaling for your end users, the delivery of your content, is by using one of our inherent capabilities called collapse forwarding, where, and this is particularly interesting for live, when there's a large number of viewers coming to the same CloudFront Edge node to download the exact same manifest file. CloudFront will collapse all of those requests and send only a single request back to the origin, so that the origin can then respond back with the manifest file and then deliver that out to all of your viewers. But if you're forwarding headers or cookies or query strings, then that forces CloudFront to include those headers as part of the cache key. So then it becomes unique requests back to the origin for different viewers. So that's something to keep in mind. And then we talked briefly about signed cookies versus signed URLs, whereby signed cookies allow you to write one cookie to your end user's or viewer's browser or device, and then all of the fragment URLs can also be access controlled based on the presence or based on the signature in the cookie. Let's talk a little bit about availability best practices. So now we're into some of the general best practices when using CloudFront. And one thing to note here is CloudFront is designed for high availability. So there's a lot that the CloudFront service already provides just by the virtue of using the CDN. But there are also certain things that you can do in addition to optimize for higher availability. So for instance, you could use monitoring, alarming, and notifications functionality that provide. So when you're using CloudFront and distributing content, you can see near real-time monitoring of your metrics in CloudWatch. We provide 6 different metrics that are available in near real time. You can look at the number of requests, the bytes downloaded, error rates, and so on. And you can also configure alarms on these metrics, and that's standard CloudWatch functionality, and standard CloudWatch pricing for that. The monitoring itself in CloudWatch, there's no additional charge, but you can set up alarms so that you get notified when a certain threshold is breached, and then you can take certain action. When it comes to availability, one of the other things you can do is configure custom error pages with CloudFront. Really, the most important thing here is this helps improve your customer experience, so that instead of seeing some generic error message, your customers are actually seeing a branded page that says that, hey, the page that you tried to look for cannot be found. And one thing to keep in mind as you're configuring error pages or custom error pages is to have these error pages be hosted in a server that's not your primary web server, right? So you can host these error pages on Amazon S3, so that so that even if your web server is having issues, then the CloudFront Edge or the viewers are getting 500 responses, we can still deliver the custom error page from S3. And the last thing here is to set a low error caching minimum TTL. So that for 15 seconds, the example I've provided here is 15 seconds. So if an error is detected, then CloudFront will respond back with the error page and keep that error page in cache for about 15 seconds. And then after that, check back with the origin to see if the origin has become available again, or if the file, in case of 400 series errors, is now available. When you think about availability, also think about how you can actually design for failure and how you can make your entire web application more available. So we've referenced origin being unavailable a couple of times, One of the ways in which you can architect to make sure that the origins are more highly available is by using Route 53. So in this case, this diagram shows how CloudFront is trying to reach your origin server, which is an elastic load balancer, but for whatever reason, it's unavailable at this moment. So now you can configure Route 53, which is our DNS service, to do health checks and have two different origin locations or two different ELPs, and continuously health check and make sure that when an origin is available and when it's not, so that as soon as the origin, one of the ELPs becomes unavailable, Route 53 can respond to CloudFront and tell CloudFront to go to the other ELB because that one is available, and then fetch the content from that origin server. So overall, when you think about higher availability, CloudFront is already architected for high availability. We have an availability SLA that's available on our website that you can look at, but there are some of these other things that you can do, and more specifically, the more you can cache with CloudFront and configure the error pages or use Route 53 to design around failures, the higher levels of availability you can achieve for your entire application. Let's talk about security a little bit. Again, similar to availability, these are just some of the things that you can do to take advantage of the security features that CloudFront provides and achieve higher levels of security for your application. So CloudFront offers the capability to do end-to-end HTTPS. So you can have HTTPS between the browser and the edge, and then also between the edge and your origin servers. So the way you configure that is on the CloudFront distribution, you say all HTTP requests should be redirected to HTTPS, so that the edge server can only receive HTTPS requests, or HTTP gets redirected to HTTPS. So everything coming in is HTTPS. You can also set up your own custom SSL domain or SSL cert at the edge, so that or you can use the CloudFront.net cert that's available and accept only HTTPS connections. And then between the edge and the origin, you can set the match viewer policy for your origin protocol policy, so that CloudFront will also make connections and requests off of your origin servers over HTTPS. So this way you get end-to-end HTTPS encryption between the user and CloudFront Edge, as well as between CloudFront Edge and the origin. CloudFront is also integrated with AWS IAM and AWS CloudTrail. A lot of customers really like these services because they can then regulate access to their CloudFront APIs or console. That's what the Identity and Access Management Service provides, and you can regulate which users have access to what actions for your CloudFront distributions. And then on the CloudTrail, with CloudTrail, you can record and keep log of all of the CloudFront API calls, and have a history there for security analysis, for compliance auditing. So in combination, these two services give you more visibility and more access control to your CloudFront resources. Let's talk a little bit about the performance and cost best practices. From a cost of SSL perspective, as I was alluding to, there are multiple ways in which you can configure SSL or HTTPS delivery via CloudFront. You can use the start.cloudfront.net SSL cert, which is a shared cert. So when you create a CloudFront distribution, you get your own unique CloudFront domain name, which is a third-level domain for the CloudFront.net domain. And you can always have your viewers can always download your content using HTTPS on that CloudFront.net domain name. Or you can also have your own SSL cert and use your own domain to deliver your content. And there are a couple of different options for doing your own custom SSL. You can use either SNI, or you can use the dedicated IP option. So both of these options are described in more detail in the documentation and also on our website. But SNI is something that most of the modern browsers support, whereby the domain name is actually sent through to the origin server, and the origin server or the cache the edge cache, in this case, doesn't need to just rely on an IP address to hand out the right cert. You can also use CloudFront reports, where we have reports on the top browsers that your viewers are using to see whether or not those browsers have support for SNI. The reason for SNI versus dedicated IP, that decision is because SNI, SSL is available at no additional cost with CloudFront, whereas dedicated IP comes with a monthly fee that you have to pay. So that's a decision that you can make based on what types of browsers your or clients your viewers are using, and then decide between SNI and dedicated IP and what's right for you. You also have the option to seamlessly switch between these SSL options. So you can just go to the management console or use the API and seamlessly switch. Just a couple more points on the SSL cost. So the SSL certificate, if you're using a custom SSL cert with CloudFront, the pricing is based on each certificate ID. So you upload your certificate to IAM and then associate that certificate with one or more CloudFront distributions. So you can use a single SSL certificate with multiple distributions as long as they're under the same account, because it's the same IAM certificate ID, and you get charged only once if you're using the dedicated IP SSL option. But if you have, and there are multiple ways in which you can sort of use fewer SSL certificates. So for instance, if you have multiple second level domains, you can use a single UCC cert. Or for multiple third level domains, you can use a wildcard cert. So CloudFront allows a variety of different SSL certs that you can use with CloudFront. So you need to look at your use case and how many different domains you're using for your viewers to be able to access your content, and accordingly you can select the right type of certificate. One of the other features that CloudFront has is called price classes. And what price classes are is, think of them as routing maps, where the default option in your CloudFront configuration is price class all, where CloudFront uses the entire network of 53 edge locations to deliver your content. But if your users are primarily in the US and EU, you can also use, for instance, price class 100, where CloudFront will only use our US and Europe edge locations to deliver your content. So here, the trade-off is that if you do have a few users that are outside of the US and EU, CloudFront will be delivering your content only from US and EU locations. So those users outside of US and EU will have a little bit higher latency, but this is a cost optimization feature because you will only be paying US and EU prices for all of your delivery to your global end users. So again, this is something that you need to think about in terms of what is your level of comfort with the latency versus cost trade-off for your use case. But there are a few options available to select different price classes to enable that. Domain sharding. So most browsers will open a limited number of parallel connections to the same domain. The way this benefits is that the browser can start downloading multiple objects at the same time. So you can shard, but the number of parallel connections that browsers will open is limited. So to increase that, what you can do is you can shard assets over multiple domains. So you can use a.mysite.com and b.mysite.com. And then what the browser will do is the browser will treat those two different domains as totally different, as totally separate when it comes to making parallel connections to the server. The reason I say it's a balancing act is because if you use too many domains, and I intentionally say too many because I think it's vague in terms of where that limit lies, but you could see degraded browser performance. So it's something you need to look at and test out. But in general, if you're using, say, 2 to 4 different domains, then you can multiply the number of parallel connections the browser will make. And if you think about a typical web application, you really have hundreds of tens or maybe hundreds of objects on a single web page. So it can be beneficial to have those spread out over different distinct domain names. You can configure multiple CNAME aliases for the same CloudFront distribution. And you can also use wildcard CNAMEs with CloudFront. So you can just say star.mysite.com. And then you have the flexibility of using in your content management system, or as you're using different domain names and sharding your domains on what you want that to be, or what you want that third level domain to be. You can also use Route 53's ALIAS records. So this is another cost as well as a performance optimization feature. So with Route 53, the way the ALIAS records work, if you're not familiar with Route 53 ALIAS records, they're very similar to CNAMEs, but the three distinctions are DNS queries to ALIAS records are free of charge, so that's where the cost optimization comes in. And then unlike CNAMEs, you can create ALIAS record for your zone apex. So this is actually a really interesting and functionality, because zone apex is where you're trying to create a CNAME to your second level domain without the www, and you can do that with ALIAS records. And then finally, ALIAS records result in less or fewer DNS lookups when resolving your CNAME to your CloudFront distribution, because with ALIAS records, Route 53 will translate your CNAME directly to a CloudFront IP address, rather than doing the intermediary step of resolving the CloudFront.net domain in the case of a CNAME. And the last topic I want to talk about is analytics best practices. So we have a variety of different reports that are available in the management console for you to learn more about your usage, about your viewers, and about your content, and how CloudFront is delivering your content. And some of the ways in which you can use these reports is you can look at, for instance, the top countries that your viewers are visiting from and downloading your content. And you can learn from that and personalize your content for your end users. So if you look at this chart, you see China is the second most visited, or viewers from China are the second most category of viewers, second highest category that are visiting your website. So you can consider creating a localized language version of your content, and the way you can vary that in the CloudFront's cache without changing your URL. So under the same URL, you can have CloudFront detect and forward the end user's country code to your origin, and then when the origin responds back with that, with a customized version of the content, you can have that be cached to CloudFront under the same URL but under two different country codes. So for the US, that could be an English version, and then for China, that could be a separate version. And then the last thing is turning on CloudFront access logs. So I highly encourage everyone to do that. There's no real cost for turning on CloudFront's access logging functionality, and the way access logging works, it's not turned on by default, so you have to go and enable that. So it's an optional feature, but once it's enabled, CloudFront will deliver the access logs for all content that we deliver to end users. So these are standard W3C compliant access logs, and they're delivered to an S3 bucket that you specify. And there are many benefits to doing that. You can run additional analytics for diving deep into your usage beyond some of the statistics and reports that we already provide. You can also identify the specific request IDs if you're having some issue with the CloudFront service, and then you can provide that request ID to AWS to help with debugging that issue. And then cookies and query strings can also be logged, even if you choose not to forward these to the origin. So this can provide you valuable information in your access logs without actually varying your content on that, and without lowering your cache hit rates. One of the other things you can do with access logs is you can have a Lambda script, the AWS Lambda script, to look at your S3 bucket, and anytime access log is put, which CloudFront continuously puts throughout the day access logs into your S3 bucket, you can automatically trigger processing on that access logs. So that's really, sort of, again, like I said, based on talking to customers, these were some of the best practices that I wanted to share with you today. Hope these, have been informational and helpful for you. For a lot of these, I highly encourage you to really think about your own specific use case and see where some of these apply and some don't. But these are the, and all of this information will be available in the recorded webinar that we will send you so you can refer to them in the future as well.